All right, mathletes, here we are evaluating and simplifying algebraic fractions. So the big thing with algebraic fractions here on this example 1, we're just going to evaluate this by doing a substitution. Big things to note is make sure when you're substituting negative numbers, I think it's a good habit to substitute with parentheses, so that helps you remember you distribute negative signs through. So if I want to evaluate this and substitute in my A, B, and C value, I can go ahead and put in 2 for A minus my C is negative 5, so I'm going to use a parenthesis because it's negative, and minus B, my B is negative 3, so again utilizing my parentheses. Simplify here, or divided by B, which is negative 3, minus A, which is 2. So as I evaluate this, I want to first write it without my parentheses, distributing negatives when necessary. So here, negative and a negative, this is going to be 2 plus 5. Negative and negative, this is going to be plus 3 over negative 3 minus 2. Okay, so as I simplify this out, I get 10 in the numerator over negative 5 in the denominator, and I know that 10 divided by negative 5 is negative 2. Okay, going on to my next example. Okay, as I want to simplify these fractions, algebraic expressions, I want to try and remember these 3 steps. 1, I want to always make sure I factorize the numerator and the denominator. 2, cancel any common factors. And when we're canceling, okay, we're looking for types of 1, meaning something divided by itself is always 1. Simplify the result. Okay, so on this this next example here, we see 6a squared times b over 3b. So I'm looking at common factors here. I notice that 3b is a factor of both. So 3b times what is the numerator? This is going to be 2a squared. The denominator, well, it's 3b, just times 1. Okay, I'm going to recognize that something divided by itself is 1, so they can cancel out, and I'm left with just 2a squared over 1, which is 2a squared. So that is as simplified as we can get. So let's make it look at a more complicated one. Okay, if we have a plus b over a, well, we can't simplify this because there is no common factor. The common mistake I see here is students recognize this as a times b over a. Okay, and this we can simplify because we have common factors. Those would cancel out, and this is equal to b. Okay, so we got to be very careful. If we see an addition sign, put up a red flag and say we cannot simplify because it's not factor. Okay, example of this could be, well, let's let a be equal to 5 and b be equal to 3. If we do a plus b over a, and by substitution, we would get 5 plus 3 over 5, and we get 8 over 5. Notice, if you try and cancel these out here, or the 5s and the 5s here, you would be trying to make a statement that 8 over 5 would be equal to 3. But that's not the case. We cannot make that mistake. But if it's multiplication, and we have 5 times 3 over 5, well, we know that this is 15 over 5, which was simplifies to 3. We can also see that if the 5 divided by 5 simplifies to 1, 1 times 3 is 3. That works. So be careful. We can only simplify. We cannot simplify something if it's multiplication. If it is, sorry, not multiplication, but addition. Okay, so this cannot be simplified. Okay, So the simplified answer would just be a plus b over a. Okay, so here I'm going to drop my parentheses, so I notice that that's squared, so I'm going to get 16b squared over 2b. Well, I can factor out a 2b up in the numerator, and I get 8b over 2b. Something divided by itself is 1, and those cancel out. So then I just am left with 8b. Okay. So next one here, notice that this is multiplication of terms. So even though I have addition signs, I'm okay. So I'm recognizing there's a red flag there, but these are multiplication of terms. So when I have entire terms being multiplied together, something divided by itself is 1. And I'm just left with x plus 4 in the numerator and 5 in the denominator. And that is my simplified form. Next example, 3a plus 9 over 3a. Well, I recognize a 3 can be factored out the top. I get a plus 3 in the numerator over 3. Again, these simplify out to 1, and 1 times a plus 3 is a plus 3. Okay. Our next example here, I'm going to look and see that the numerator can be factored out as a 6 and an x. I'm going to be left with an x here minus y. The denominator can have a 3 factored out from those terms, and I get x minus y. Notice we have two terms that are considered to be 1, something divided by itself. I simplify. Notice here I have a common factor, so 6 divided by 3 is 2. And I'm left with 2x as my final answer. I could put this over 1, but not necessary. Okay. Here in my final example, I'm again going to look at for my common factors, but I factor out my 6 in the numerator, and I get a minus b over b minus a. And when I look at here, I notice that these look very similar. But on the top, I have a minus b, and on the bottom, I have b minus a. So they're rearranged. So one thing that we want to think of is if we want to rearrange it, if we have b minus a and we want it to look like a minus b, we can factor out a negative 1 up top. Okay? So if I do that, so if I do the 6th, then factor out a negative 1 up top. Okay? Negative 1 times what is a? Well, that's negative a. Negative 1 times what is negative b? I get plus b. Okay. And I can see if I distributed this back through, be the same as here. Okay. Now on the denominator, I'm just going to leave this as b minus a. Okay. So as I take this step by step, I see 6 times negative 1 is negative 6. Now here, in this part, because I'm dealing with addition, I can change the order around, and I'm going to do b minus a. The denominator, I'm just going to leave the same, b minus a. And now I notice I have something divided by itself, so that cancels out, and we're just left with negative 6. Okay, that concludes the notes for today. Go ahead and bring any questions you have to class tomorrow.